As software developers, we often focus on getting our code to work on our local machines. We write and run our code to make sure nothing broke, we debug any issues that come up, and write automated tests that run locally and on our continuous integration systems. However, checking your app locally or running automated tests on CI doesn't cover the full spectrum of the user experience. You also need to make sure your systems perform well in the real world. On a local development environment, you're the only person interacting with the app, and you're likely using a limited subset of data and infrastructure. But in a production environment, everything is different. Your application will likely be dealing with dozens, hundreds, or thousands of simultaneous requests. Every single one of your users is expecting a quick response, and the underlying infrastructure might not be sufficient to handle it. The problem is that we usually don't notice these problems until it's too late, when you begin receiving complaints about the system being too slow or alerts that your systems are crashing constantly. People will quickly abandon your app if it's not working fast or reliably for them. This is where load testing helps. Load testing verifies how your entire system handles different loads. This testing is useful to understand how the system behaves under typical and peak loads to ensure it can handle both expected and unexpected traffic. Load testing generates simulated traffic known as virtual users. These virtual users interact with your application through the flows you want to test, replicating the same behaviors as a real user would. Typically, your load test will send hundreds or thousands of virtual users to your site or API to verify how it reacts under that stress. Running load tests nowadays is easier than ever, thanks to plenty of load testing tools we have available. My personal favorite load testing tool is Artillery. Artillery is an open source load testing platform designed to test the performance and scalability of your web applications. You can build load tests using YAML configuration files, which are easy to write and read for developers. It supports different protocols from your standard HTTP APIs to WebSockets, GraphQL services, and more. Artillery is also highly scalable, thanks to its built-in support for running tests on AWS Lambda and Fargate. In short, Artillery has everything you need to quickly get started on your load testing journey. In this video, I'll go through the basics of creating load tests on an API using Artillery to show you how simple it is to get these tests running. Let's get started. For this video, I'll build a few load tests using Artillery. The application I'll use for this is an API I built called Airport Gap, which I've shown in other videos on this channel. Airport Gap is an HTTP API I built to help developers and testers improve their automated testing skills. For this demo, I set up the Airport Gap in a separate testing environment to check how the system behaves under higher than normal usage. Ideally, you'll want to run your load test against an environment that reflects your production environment or even against your actual production environment. A common mistake I've seen is running load tests in environments that don't mirror their production systems. This can yield misleading results, so please keep that in mind when doing your own load testing. Let's get into setting up Artillery on our local environment to begin writing load tests. Artillery is built using Node.js and runs on Windows, macOS, and Linux systems. You need to install the latest LTS release of Node.js. You can find the details for setting up Node.js for your local development environment on their website. Alternatively, you can use a version manager like NVM or ASDF to set up Node.js on your systems, which I highly recommend for development environments because it lets you switch between different versions of Node. Once you have Node.js set up, you can install Artillery using the npm package manager. I'll install Artillery globally on my system using npm install with the global flag, Artillery, and latest. Using the global flag will let us easily run the Artillery command for our tests in our projects. That's all you need to get Artillery installed on your system. We can confirm the installation by running Artillery version, which prints out the current version of Artillery installed in your system. With Artillery installed, we can begin writing our first load test. In this video, I'll write these tests in an empty repository for demonstration purposes. In most cases, you'll want to include these alongside your code. As mentioned earlier, Artillery works with YAML files, so we'll create a new file in this directory. I'll call it airports API test.yaml. You can name your test files anything you want, but it's a good practice to use descriptive file names that reflect what you'll test. An artillery load test configuration will typically have two top-level keys, the config key and the scenarios key. As suggested by the name, the config top-level key contains the configuration to define how the load test runs, like the URL of the system, the amount of load to test, and setting up plugins. The scenarios top-level key covers the steps that each virtual user will take throughout the test. Let's go through the config key first to configure our test. The first thing we want to do is to tell Artillery which URL we want to test. To do that, we'll use the target setting. This setting will have the base URL we want to test. For the Airport Gap application, our base URL for this demo is https demo.airportgap.com/API. Keep in mind that this is the base URL and not the actual endpoint we want to test. Later, when we begin defining our scenarios, we'll specify the endpoints we want to use for each step. After telling Artillery our base URL, we'll next define the load we want to generate for the test. We'll do this by using the phases key. Here, we'll tell Artillery how many virtual users to create and for how long. Depending on what you want to accomplish with your load test, you can define a phase in different ways. Artillery supports 4 different types of phases. You can send virtual users at a consistent rate every second. You can gradually ramp up or ramp down the number of virtual users over time. You can send a fixed number of virtual users for a specified amount of time. Or you could set an explicit pause to tell Artillery to not generate any new virtual users for a duration of time. Artillery lets us define multiple phases for a single load test, and we can mix different types of phases. To start, we'll create a single phase that sends a consistent amount of virtual users per second to our API. Under the phases key, we'll start a new sequence or list for our first phase. The first key I'll set in this phase is the name. This attribute is optional, but it gives us a descriptive name for this phase, so we'll set it to warm-up phase. Next, I want to specify how many virtual users I want Artillery to send to my scenarios. This is done with the arrival rate key. Since this phase is to warm up the API, we'll keep this number low, so I'll ask Artillery to send 5 virtual users every second. Finally, we need to specify how long we want this phase to last. The duration key lets us define the number of seconds for this phase. I'll set it to 30 seconds for the warm-up. With that, we have a load phase ready to go. The next step is to define our scenarios. To keep this simple, I'll also define one scenario to test a single endpoint. The Airport Gap API contains a few public endpoints that we can access quickly. So let's take the airports endpoint for our first load test. Under the scenarios key, we'll create a new sequence and begin by setting up the name attribute. Similar to how we named the load phase, this optional setting will help describe the scenario. We'll call this scenario fetch first page of airports. Next, we'll set the flow key. This attribute is required and contains a list of the operations that each virtual user will perform. A flow can contain multiple operations to simulate an end-to-end user experience. I'll go through that later. For now, I'll create a single operation for this scenario. We're testing an HTTP API, so we need to tell Artillery what type of HTTP method we'll use. The endpoint we want to test uses GET, so we'll open a new sequence under flow and set the top-level key for this list as GET. Under GET, we can set additional attributes for this operation. The only one we need for now is the URL attribute. This attribute is the request URL and will be appended to the target URL we set in the configuration earlier. Here, we'll set the URL as airports, which is our endpoint to test. And that's all we need to run a load test using Artillery. To recap this configuration, we've configured Artillery to set a base URL, define the load phase that would generate 5 virtual users every second for 30 seconds, and each virtual user will send a GET request to the airports endpoint. One thing I do want to mention is that whenever you're writing load tests for artillery, you need to pay close attention to indentation. YAML is pretty strict about its structure, so you need to make sure these attributes are indented correctly. So let's save this file and let's run this load test. In the terminal, we can run this test with the command artillery run and the name of our YAML file, which is airports API test.yaml. Artillery begins executing the load test and launching virtual users as we define them in our code. Every 10 seconds, Artillery prints out a summary of the metrics it has collected during that time, so we can see data like successful requests, number of virtual users created, and different response times. When Artillery finishes with our defined phases, we'll have a complete summary of the load tests. Here, we'll see that Artillery generated 150 virtual users, and it looks like we had no errors during the test. We also see different response time metrics like the minimum, maximum, and 99th percentile. All this data gives us a clearer picture about how our systems behave under load. Let's expand on this test to show what other functionality Artillery provides. I want to add a new phase that gradually ramps up the number of virtual users to simulate a steady increase of traffic and check how the system reacts. I'll add a new phase under our existing one. For the name, I'll call it ramp up phase. I'll set the arrival rate to 5 as we did before. But for this phase, I want to run it for a full minute, so I'll set the duration to 60. This phase looks the same as our previous one, except the duration, but we'll add a new key called ramp2, which tells Artillery that we want the number of generated virtual users to go from our initial starting point, which is 5, to a desired number of users. In Artillery, setting a ramp works in a linear fashion, meaning it'll send more and more users at a linear pace until it reaches the number we specify. For this example, we'll say we want to ramp up to 20 virtual users. That means that the ramp up phase will begin with 5 virtual users every second, then go up to 6 a few seconds later, then 7, and so on until it reaches 20. Let's save this file and run the load test again to see it in action. After the test complete, we can see the summary as before. This time, Artillery created 900 virtual users. And it seems like we still didn't get any errors, so our system is still looking good, at least for fewer than 20 concurrent users, although we could already see that there's some slowdown beginning to happen. Scrolling up, we can see when the different phases start and end, so we can keep track of them if anything happens during execution. So this basic example hits only one public endpoint. However, on most real-world APIs, you'll have users hitting multiple endpoints during their interactions with your application, and they'll be using authenticated endpoints as well. Let's see how we can load test these flows using Artillery. For our next load test, I want to go through the flow of a user authenticating with Airport Gap to get their API token for accessing protected endpoints, then fetching their list of favorite airports, then clearing their favorites list. I'll create a new file called authentication test.yaml, and I'll copy over the contents of the existing test. And I'll keep the phases for now, but I'll delete the scenarios just so we can start fresh with a new one. Well, first, we want to make a request to get our API token. Looking at the Airport Gap API documentation, we can find the post tokens endpoint, which accepts an account email and password as its parameters and returns the API token in a JSON object. For this scenario, I'll add a name and call it authentication endpoints. Then for the first operation under the scenario's flow, I'll make a post request. Now set the name to fetch token and the URL pointing to tokens. We also need to send the email and the password in the request body. This API handles JSON requests, so in this case, we can specify the JSON key to tell Artillery to send a JSON object in the request body. Under the JSON attribute, we can set key value pairs of the parameters we want to send in the body. We'll specify an email parameter with the value of a test user in the system. And we'll also send the password parameter with that user's password. This handles the request, but we do need to save the token from the response. Artillery allows us to parse a response from an operation using the capture attribute. This allows us to save and reuse values for subsequent requests. We can parse and reuse values from a JSON response by specifying the JSON key under capture as a list. And then we can use JSONPath, which lets us query and extract portions of a JSON document. The post tokens endpoint returns the JSON object with a single attribute called token. So we can fetch this value using $token, which will parse the data that we need. As a brief explanation of this JSON path expression, the dollar symbol indicates the root of the JSON object. The period after is called the .child operator, which denotes a child element. In this case, the child element of the root object. Finally, the token portion is the attribute we want to fetch for our value. This is a simple example, but JSONPath is pretty powerful to know when testing JSON-based APIs. I'll leave some resources for learning JSONPath in the video description. We also need to specify the name of the value we capture so we can reuse it later. We'll do this using the as key and keep it simple by calling our variable token. Let's add another operation to our scenario which uses this authentication token. The Airport Gap API has a get favorites endpoint, which requires an authentication token. It fetches the list of favorite airports a user has saved in their account. Let's add this to our scenario. We'll add a new get operation after fetching the token. We'll set the name as fetch favorite airports and set the URL to favorites. Since this endpoint requires authentication, we need to figure out how to pass our token to the request. The Airport Gap API documentation tells us we need to pass the token using the authorization request header, setting the value of bearer token equals our token. In Artillery, we can add a request header to an operation using the headers key. This key also takes key value pairs, where the key is the name of the header we want to send, and the value is the request header's value. In this case, the key will be authorization, and the value will start with bearer token, the equal sign. So how can we include the token we captured from the previous request, labeled as token? We can interpolate any values we captured using double curly braces. So in this case, we'll use the variable name, which is token, enclosed in double curly braces. So it'll look like this. This will send the token in our request to authenticate. The last operation in our flow is clearing the list of favorite airports. Although this operation isn't particularly useful for this test, since each virtual user will clear the list, we'll include it here just for demonstration purposes. We can find this functionality under the delete favorites clear all endpoint. It's also an endpoint that requires authentication, and now that we know how to authenticate using Artillery, we can quickly add this to our scenario. We'll add a new operation to this flow, which is a delete request. We'll set a name of clear favorites, making sure to indent, and we'll set the URL to favorites clear all. Let's also copy the headers from our previous requests so we can authenticate properly. We now have one scenario that covers a longer end-to-end flow, which each virtual user will go through from start to finish. Let's see how our system handles this extra load. In the terminal, we'll run this test with Artillery run authentication test.yaml and let it go through the process. Now that the test is finished, we can see that our systems have begun to show signs of not being able to handle these requests. We can see that Artillery still generated the same amount of virtual users, but we can start seeing that a lot of them failed, and we start to see some errors like some timeout errors and some failed captured errors and some 429 HTTP response errors as well. So we're already seeing that this test is starting to show where our systems are beginning to crumble a little bit. In our previous test where we were hitting a single endpoint, we couldn't see any issues. But with this more extensive scenario covering this essential user flow with the same number of virtual users, things begin to break down a little bit. So if this were a production application and not a test environment, which I'm doing right now, I would begin looking at whether the strain is happening on the application level or on the infrastructure level. I would begin to isolate different components and endpoints and begin rerunning these tests to make sure that the changes that I make are making some improvements or if I need to investigate somewhere else. So this goes to show the importance of load testing and how going through longer flows during these tests will uncover potential problems that could otherwise go unnoticed. Even simple tests like these using Artillery will help deliver a more reliable application to users. And I really encourage developers to spend a little time verifying how well their systems work under load. This video is a quick example of how simple it is to create load tests using Artillery. With just a few lines of code, you can trigger hundreds or thousands of virtual users to your API to make sure that your systems can withstand high traffic volumes. These tests can help you prevent scalability issues in your application, so you're not caught by surprise with an unexpected surge of traffic. The cool thing about Artillery is that what I've shown in this video barely scratches the surface on what it can do to help you load test your applications. As mentioned at the beginning of this video, Artillery has support for running your tests from AWS, plugins to extend its functionality, and tons more. Let me know in the comments if you're interested in a future video covering some of these topics. If you found this video helpful, consider subscribing to this channel for more tips on helping developers ship their code confidently, from development to deployment. You can also check my website for more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.